April 4th, 9.2 notes. Okay. All right, little review, okay? So they give us a point here, right? They give us a point. They give us a set of points here, okay? How do we know that this is a function? Function means the x values do not repeat. Just the x values do not repeat. Okay? That's what a function is. When we look at a set of points, the x values cannot repeat. If they do not repeat, then we have a function. Okay? We can also do the horizontal line test, right? So this is a function. Passes the vertical line test, that's a function. Okay. This is not a function, right? Does not pass the vertical line test. Okay. So if the x's do not repeat, it is a function. If neither the x nor the y's repeat, then it's a one-to-one function. Neither x nor y values repeat. Okay? Nothing repeats. Nothing. Not even, I don't know. All right? So this first one, is it a function? Do our x values repeat at all? No. No, so it is a function. Is it one-to-one?
Yes.
Yes. Nothing repeats. Nothing. No thing repeats. Therefore, it is one-to-one. Yes, one-to-one.
What is that?
One-to-one?
No, that little.
Sorry, it's a little arrow. Not all of us were blessed with fine motor skills.
Oh wow, that's so nice.
Wait, one-to-one.
I can also make a right angle arrow. All right, what about this next one? So is this a function?
Oh, so like, is there an answer for A, or it's just?
Oh yeah, it's a very good question. The answer is yes.
Well, I just like.
No, yeah, no, yeah,
Actually, no.
Because we're not solving, it just has to determine whether each function.
Yeah, no, it's a good question. All right, so is this a function?
No,
Why do you not think it's a function?
because there's two negative ones.
Okay, so a function just means the x's don't repeat.
Oh.
So it is a function. Is it one-to-one?
No.
No. Why is it not one-to-one, Izzy? There's two negative ones, right? So
So one and
a function, but not one-to-one. I love one-to-one functions. It's a function, but it's not one-to-one, right? None of the x's repeat, so it is a function, but we have a repeat for the y values, so it is not one-to-one. It's just a regular old function. It's not special, okay? It's not special.
You probably heard that function feelings.
I know. I don't care. Okay, so we can do this graphically as well, so we can describe whether a set of points is a function or a one-to-one function. We can also do that for graphs, okay? So the vertical line test, do the vertical line test. All right, that's going to tell us whether it's a function. We also have the horizontal line test. function passes both of them, it is a one-to-one function. Okay? This is a little review from last semester, from like October, I think. Wow, that was a rough month. October was horrible. Anyway,
Why was it bad?
my mom had her back surgery.
They,
She was on heavy nerve drugs all month. Can't remember anything. She can't. All right, so let's do the vertical line test for this graph right here, okay? So I'm just going to draw a bunch of vertical lines. Does my graph ever pass through a vertical line more than once? No, so it passes the vertical line test, so it is a function. Yes, a function, okay? Yes, a function. Yes, function. Okay, let's talk about the horizontal line test. Does it pass the horizontal line test?
no.
Why does it not?
Because look at all those lines.
That's just how it is. So it intersects a lot of these horizontal lines more than one time.
Yeah.
So that means it fails.
It failed.
Yeah, fails the horizontal
So
line
it's
test.
not 1 to 1.
Yeah, correct.
So it is function. So like on a quiz or test, we put like yes or no and that's it.
Yeah.
So we don't have to put like.
So this is like the 3 points of the test.
Hopefully, yeah. The whole test should be 3 points.
So we don't have to write like if they all or like it's not 1 to 1, we just say yes or no.
Yeah, just say yes, a function fails horizontal line test and not one to one. That's fine. Yes or no.
Oh, okay.
Okay, this next one, is this a function?
Yes, function.
It is a function. Is it a one-to-one function?
Yes.
Yeah, right? So no horizontal line nor any vertical line passes through the graph more than one time. That means it is a one-to-one function. So yes for both. That means it's a one-to-one function. It's actually really important. This is actually very important in upper level mathematics. Functional analysis. I haven't taken it. I want to though. All right, this next one. Is it a function?
Yes.
Is it really? Okay, good. I'm just messing with you. Yeah, it is. It's a function, yep. Is it a one-to-one function? No. Okay, good. Yeah. All right, so yes, a function, but not one-to-one. Bless you. I think a one-to-one function is also called a monotonic function. It's also called an injection. Yeah, it's an injective function. Sound smart. Get your $16,000 worth.
I think it's gonna be 17.
17?
I think it's moving up. That's what for collision?
Yeah,
Yeah, that's
Isn't it
not
already?
it's all good.
I know group ops is like.
All right. Ooh, now we got to find the inverse of each function. Ooh. Ooh. Inverse of each function. It's also written. It's commonly written as if you have a function f of x, its inverse is often written f to the negative 1 of x. Okay. All right. That doesn't mean f, like that's not an exponent right here. I guarantee this is not an exponent. Anytime you see f parentheses x, this number here is not an exponent. It's just like a name. It's like a label, right? Right? Like the logo on my shirt, that's not a number. That's just a label, right? Same thing here. That's just a label. This means f inverse, the inverse of f. Okay.
Oh, why does it
What's that? It does look like a negative one. They just use the number to name it that. It's not it's not like a number that like does an operation. It just like names it. Like imagine if like you had a child and you named it -1. That's
Negative 1.
-1.
Negative 1. That seems like something.
I'm naming my child quadratic. Quadratic, come back.
That would actually kind of be like you can make it a
Can you
quad.
just get my Q or something?
Oh,
Is
yeah.
Q for Quentin? No, it's actually quadratic. Anyway.
What if he's like bad at math?
That's embarrassing.
He
Wait,
gets
you?
this one.
Right. Mr. Rushmore.
Now my kids, I'm working one-on-one with my kids from a young age. If I have kids,
Are you gonna put in Kumon?
I won't make them, but I'll encourage them
What?
if they want to. Jagging my sister.
I asked.
age 3.
It's like a math tutoring center that like some parents will like force their kids to go to. Not because they need help, because they want them to like.
Come on, kids. No, it reminds me of that. What's that one show on Netflix? The one where like.
No, some kids really like math. Like I would have loved to
the
do one.
Asian one.
Like it's for kids who like really like some kids really like math.
No, most parents just make them.
Okay, find the inverse of each
Go
one.
get better.
Okay, we're done reading.
Okay. For a set of points, what you do, it's actually pretty easy.
Multiply by -1.
Nope, just flip the x and y's.
That's what I thought too.
No. It was on like.
Good, you thought correctly. Okay, so
No.
I'm just gonna flip.
I forget what it's called.
Just gonna flip them.
2, 1.
So that's gonna be 2, 1, 3, -1, 4, -3. Okay. That's what we call A inverse. A to the -1.
That's all it is.
Yeah, for points, yeah, for a set of points. For a finite set, a countable set of points. Okay, so for C, you do the exact same thing. 2, 6,
I'm sorry,
9, 9, 4, 1, 5, -1. So you just flip the x and y values. You can't get over it. Yeah, so that's what you do for a set of points to find the inverse, okay? All right, here we go. Pre-Cal had some trouble with this next one in the fall. So it's now the spring. It's very instructional though. I'm going to give you a set of instructions for the next part. When it's a whole function, so it's not just a set of points, when it's like a whole graph like this, inverting it or finding the inverse, it's a little more in depth. Okay. So what you do is, okay, so everywhere you see f of x, replace it with an x. Okay, that's step one. So we have an f of x right here. We're going to make it x. That just becomes an x. Okay. Everywhere you see an x, replace it with a y. Okay, so I have a x right there. It's going to become okay, so f of x became an x became a y. Okay. Third step, solve for y and switch y back to f of x. Or no, you're going to switch it back to f to the -1 of x. Okay. So let's solve this for y, okay? So we got to subtract 3 from both sides. Divide both sides by 2y. Okay, and then change y just to f to negative 1 of x. That's it. What's that? Yeah. Teaching all this, I taught this to pre-cal in the fall, so that was kind of nice. Okay, how we feeling? How we feeling? All right, so going on to this next one. Okay, I'll pause. Really?
Because I've done my NDEA on purpose.
What?
Like my NDEA, because I was gonna like have a really high progress by the end of the year. And I did so bad and they put me in the cat though. Yeah, I think.
Wow. Forget what field?
Yeah. I've been already. Definitely learning.
All right, that is a good lesson to learn. Do your best. Do your best. Okay. So everywhere you see an f of x, right? I want to make that. I just want to change that to an x. X. Okay. Everywhere I see a y. Or sorry. Everywhere. Yeah. Sorry. Everywhere I see an x, I want to change that to a y. So x equals 4, and then y. Minus 5 all over 3, okay? And then I want to solve for y, okay? So I'm going to multiply both sides by 3. I'm going to add 5 to both sides. Okay? And I'm going to divide by 4. So I have y equals 3x plus 5 all over 4. And then the last step, instead of writing y in my answer, I'm going to write f inverse, f to the negative 1 of x equals 3x plus 5 all over 4. How are we feeling about that? Okay. Can I move on to C yet or no? No? Okay. I will not.
I'm good.
Okay.
Thank you.
Alright. Alright, sounds good. Alright, so for C, same deal, right? Everywhere I see an f of x, I want to change that to an x. Everywhere I see an x, I just want to make that a y. Okay, then I solve for y, okay? So let's cube both sides to cancel out the cube roots. Subtract 9. Y equals x cubed minus 9. Okay, and then instead of writing y equals, I write f inverse equals. Alright? D, right? Everywhere I see an f of x, I want to change that to an x. Right? Everywhere I see an x, I want to change that to a y. And solve for y. So multiply both sides by 7 minus y. Multiply both sides by x. And subtract 7 from both sides. Divide both sides by -1. And instead of y, we want f inverse. All right. How do you feel about this? Questions, comments, concerns? All right. I have a question real quick. Okay, good. Interesting. 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 Okay.
Interesting.
It is. I don't think Mrs. Hollis would have put that big of a curveball on here. Okay, so number 5, it says, find the inverse of each function and graph the function. Okay, so we're just going one step further. We're going to graph the function and its inverse on the same set of axes. Okay, this one's pretty easy. Let's label this R. Let's label R the red function. Okay, what's R inverse? We'll make this the blue function. What's R inverse going to be? We do what here? Yeah, so just flip. Okay, so that gives us our inverse. Let's graph. Just going to graph. So let's graph the red function first. -9, 6. Yeah, I don't know. -6, 9. 3, 4. I'm just eyeballing it. Okay, so that is the red function. Let's graph the blue now. 6, -9. 9, -6. And 4, 3. And then let's graph the line y equals x. All right, so if I had any artistic ability, you're supposed to see that the blue points are just a reflection of the red points over this diagonal line here. Let me see if I can show you with Desmos. Nope. Nope. Here we go. Yeah. So let's graph the red. love Desmos. What? All right, so you see how like the blue points are just reflected across this green line?
Yes.
Really? Okay.
Yeah.
All right, so that's how that works. So yeah, so in general, when you graph a function in its inverse, you're going to see a reflection across y equals x, across that line. Okay, so if we can do the same thing with 3x plus 5, right? Let's find the inverse real quick. We get x equals 3y.
I can't see what you're.
Sorry. Okay, so let's find the inverse of that function real quick. Okay. I'm going to do this on Desmos because I have horrible artistic ability. What's that?
How significant is it to the green line?
Significant. Gosh dang it. Gosh dang it. I hate fractions. All right, so I got it up on Desmos for you guys. All right, so the function, the green is the inverse, and you see how it's reflected across the purple line? Yeah, see that? Okay, cool. Okay, I'm gonna go ahead and put the next one in Desmos first. Okay, so we've got this function. We should expect the inverse, right, to just be reflected across that diagonal line, right? We should expect the inverse to look like this blue function, but reflected across that black line. So it should be like this, like a little S like this. Okay, let's do that. Okay, let's find the inverse. So we're gonna have x equals y cubed minus 2. Add 2 to both sides. Okay, how do I undo a cube? Cube root, thank you. So I'm going to have cube root of x plus 2 equals y. Okay, so let's look at that. Sorry, that should be x to the 3. So the inverse should be just reflected. So there you go. You guys see how it's a reflection? All All right, any questions?
Like 2 weeks? No, 1 week.
All right, can I move on or no?
Can you go back to like the page where you're like writing the stuff? Oh, okay.
All right, so when you guys are finishing copying that down, I'll write down the steps for the next one.
I'm not. I just saw the page.
Okay, so the way we do these, so this next part, okay, we're going to do F circle F inverse and F inverse circle F, right? What does that mean again? It means we plug the second function into the first, okay? So we just plug them into each other and show that that equals x, okay? So F of F inverse of x, right? So that what I'm going to do is I'm going to write down 3x plus 2, but everywhere I have an x, I'm going to replace that with an F inverse of x. Okay. Let's write in F inverse 3 times x minus 2 over 3 plus 2. Okay, that cancels. I get x minus 2 plus 2 is x. Okay, so that works. They both have to work, okay? And then let's do the other way around. Let's take F inverse. That's f to the negative 1. Let's plug f into that. So that's going to be f of x minus 2 all over 3. That's going to be 3x plus 2 minus 2 all over 3. Those cancel.
I think I'm a little fast.
There you go. That one works. So yes. Okay. All right. Just take a moment, write that down. Okay, we have time. Any questions here? What's that? Oh, you guys didn't write down the steps yet. Yeah. Yeah. You check on Taria too. Alright, so we're just plugging f and f inverse into each other. Is that okay? Alright, gotta do the next one. I'll try to do the next one a little slower, okay? So the first thing we gotta do, let's label these. I'll label this the red. I'll make f of x red. I'll make f inverse. That's this f to the negative 1 thingy. I'll make that blue, okay? So first, we have to check both. Must check both. Must check both. Okay, so first I'm going to do f of f inverse of x. Right? So that equals 2 times f inverse of x minus 7, okay? It's going to be 2 times x plus 7 all over 2 minus 7, okay? So it's going to cancel. You get x plus 7 minus 7, those cancel, you get x. So that works. Okay, then I have to check f inverse of f of x. Okay, so that's going to be f of x plus 7 all over 2, which is 2x minus 7 plus 7 all over 2, which is 2x over 2, which is x, okay? So since they both equal x, they yes inverses. Okay? The answer for this one is your work. Okay?
So,
Yeah.
so you put the red equation into the blue equation,
Yep.
and if it equals x, then it's yes.
Well, then it could be a yes. Yeah, so you have to check both. Then you have to plug the blue into the red. They both have to be x.
Okay. Okay.
Yeah. All right. Any questions, comments, concerns?
Those are true.
So you just plug them into each other to show that they're inverses, and you should get x for both of them. Okay, does that make sense? Okay. All right. Homework for tomorrow. In addition to the homework that all but 3 of you still have left to do, you have this white binder.